Lesson 29, uniform motion problem. All right, we've talked about uniform motion problems before. All right, keep in mind, when we talk about uniform motion, we have a rate, we have a time, and we have a distance. All right, we've talked about how rate and time and distance are related. Okay, rate times time equals distance. Right, and we've been doing problems where we've got equal distances. All right, so if the distance of one person equals the distance of the second person, then the rate times time of the first person equals the rate times time of the second person. The problems that we're going to be dealing with today deal in combination distances. All right, so we've got someone traveling a certain distance. And then there's a second distance, and it equals a total distance, or an x. All right? Keep in mind, rate times time equals distance. So the first distance is rate 1 times 1. Second distance is rate 2 times 2. Okay, but two separate distances equal one total distance. All right? And these are the types of problems we're going to be dealing with. Okay? All right, so let's look at an example of this. Napoleon walked part of the 60 miles to the site of the battle and rode the rest of the way on a chariot. Okay, so Napoleon walked part and rode part. Okay, now we know that the whole trip is 60 miles. Okay, so here's his starting point. Now this part he walked, and then from here to here he started to ride. Okay, this whole distance is 60 miles. Okay, so that's all the information that we've gained from the first sentence. It may be helpful for you to draw diagrams for these problems. Go ahead and draw it out. It'll make it simpler in setting it up. Okay, that's a lot of the issue with these problems is just getting the initial setup. Draw a diagram or sketch a quick picture of it, and that will help you. Okay, now keep in mind that each separate distance, all right, so this is distance 1 that he walked, and this is distance 2 that he rode. Each separate distance has to have a rate and a time. Okay, so let's read the rest of the problem to see if we can figure out some of this information. He walked at 3 miles per hour. All right, so the rate at which he walked is 3 miles per hour. And rode at 9 miles per hour. So the rate at which he rode is 9. Okay? If the total time of the trip was 8 hours, how long did he walk? All right, so the total time was 8 hours. All right, so we don't know what the time that he walked was or the time that he rode was, but if the time that he walked was 8, then to find out how much he rode, it would be 8 minus x, since the total time was 8 hours. Okay, now we have rates and times for everything. We have the total distance, so now we're going to plug it into our formula. All right, this is distance 1 plus distance 2 equals a total. All right, and keep in mind, distance 1 is rate times time. Distance 2 is rate times time. All right, so the rate at which he walked was 3, and the time was x. So we have 3x, plus the rate at which he rode was 9, and the time was 8 minus x, and the total is 60. All right, so we're solving for x. In order to solve for x, we're going to distribute. All right, we're going to subtract 72 from both sides and combine like terms. So we have negative 6x equals negative 12. All right, so x is going to be equal to 2. All right, so that tells me that he walked for 2 hours. And if he walked for 2 hours, then he rode for 6, because 8 minus 2 is 6. Okay, so we have found the times for both. Now the actual question that we are answering is how long did he walk? All right, so he walked for 2 hours. So 2 would be our final answer. All right, let's take a look at another example. Edward and Queen E were 54 miles apart at dawn. All right, so they were 54 miles apart, meaning our total distance is going to be 54 miles. Okay, now Edward was over here, and the Queen was over here. They were apart, 54 miles. All right, so we've got the first in and second in. Edward began the journey to the meeting place. All right, so they're meeting somewhere. So Edward began his journey at 8 a.m. at 3 miles per hour. Okay, now, Edward is traveling a distance, and for the distance, we have a rate and a time. Now, we know he left at 8 a.m., but as of right now, with the information that we've read so far, we don't know what time he met. Okay, so we don't have the time yet. But we do know that he traveled at a rate of 3 miles per hour, so we can fill in his rate. Okay? 2 hours later, the Queen set out to meet him. Right? Again, the Queen traveled a distance, so she has to have a rate and a time. They met at 4 p.m. Okay, now we can figure out a time. If Edward began the journey at 8 and met at 4, what is Edward's time? Okay, it's going to be 8. From 8 to 4. Now, the Queen left 2 hours later, so her time is going to be 6. It's 2 hours left. They met at 4. How fast did the Queen travel? So we are looking for the Queen's rate. All right, we're going to use the formula: distance plus distance equals a total. Okay, rate times time plus rate times time equals a total. All right, fill in the missing information. The rate is 3, the time is 8. Queen's rate is unknown, but the time is 6, and the total distance is 54. All right, if we continue and solve for x, we have 6x is equal to 30, which means that x is equal to 5. So the Queen's rate was 5 miles per hour. Okay? All right, the next example. At noon, Rocket Man zoomed off toward Rocket Land. 1 hour later, Moonfa zoomed off in the opposite direction at a speed 20 kilometers per hour, less than that of Rocket Man. They were 11,800 kilometers apart at 5 p.m. How fast did each travel? All right, so we're looking for a rate for each of them. Go ahead and solve this problem. Okay, set it up using a diagram or using a sketch. Make sure you use the formulas, and we will check it when we come back into class.